And okay. Okay, ReLU. So we move to the next one. Remember this one? Convolutional, ReLU, and pooling. Got three. Convolutional, ReLU, and pooling. Okay. So the output of the convolutional will be moved to ReLU. ReLU mean activation function. Here also called activation function. In neural network also got activation function, and convolutional also got activation function called ReLU. So basically, it's just to this is a ReLU function. For example, this is a function that we call ReLU. Okay, rectify something. Okay, there is a paper on this why ReLU. So if you look at this just to change the value from here to something. Okay, to change the value. So let's see this. This is X. This is Y. Okay, this is a coordinate. Okay, and the function is like this. Okay, so here you got 0, y-axis, 1, 2, 3, 4. Okay, you got like this, some sort like this. So ReLU basically is understanding the function. In here you call it a ReLU function, rectify, the name of the function. Then you got here -1, isn't it? Okay, -2, -3, and so forth. So y the input, x the output. So basically the function is f y equal to x. So this is a very, very basic function. Y, let's say 3, yeah? Y is equal to 3. So what will be x? Guys, what will be x?
That 3 as well.
What is x? Anyone?
Is that 3?
So here also got 1. Okay, so 0, you also got 1, 2, 3, 4. Okay, so here also got 1, -1, -2, and so on. So y is equal to 3 here, okay. So it's become 3, yes. Betul, okay. Y sama dengan -1. X will be berapa? What is X? Anyone? Y is -1. X will be?
One? Is it correct, Prof?
Sorry?
Maybe what? X.
Okay, someone said 1, someone said 0. Any more? Any more answer? So this is y equal to 3. X will be 3. Okay. So if y is equal to 1, negative 1, so you said x is equal to 1 and another one say 0. Any more answer? Y is equal to negative 1. It is already under yellow line, so it is 0. Okay, so this is supposed to be, the answer is 0. So the answer is, you got it, Mamin? So the answer is 0. Okay, boleh eh? What if say, so you have to understand once, then that's it. In the exam, I want you to know this, the purpose of it. So later on when you read it, negative 3 is easy for you. X is, y is negative 3. X is, anyone?
0.
0, yes. Boleh eh? Okay, macam ni. So if y is negative 3, it becomes 0. Alright. So when you set value, value, I can delete this. I'm gonna post the video later on. So when you have the function, you set the activation function, I use ReLU. So you just automatically remember this graph. Okay? Remember this graph. The graph is, when people say ReLU, you just remember, okay, ReLU, I know ReLU. You just put in your mind, I know ReLU. ReLU is just simply, function is like this. Like this, the same. So this is ReLU. Whatever happen in y, the output always be between 0 and above. Whatever happen in y, the value of output will be always 0 to the above. There is no negative. So this is, okay, so this is what we call ReLU. You can have other things. Okay, you can have function like, in this case ReLU, you can have function like this. Okay, or you can have function oh my goodness. Okay, you can have function like this, it's up to you. You can have function like this, slightly different. So when you have like this, it's not ReLU, probably modify ReLU. Okay, all right. Okay, so the name of this one is, if you have like this, is some sort like ReLU, but this bar you move a little bit down, so probably you can say modify ReLU. Okay, because so in this case there is a negative value. All right, so in this case, if I put y is 4, it becomes 4. When I said 3, it becomes 3. When the input is 4, go to this ReLU function, it becomes 4, remain. When I put negative 4 here, the output will be 0. So it changed. Okay, so this changed to this one because of this function. So basically you can see that it is just take a positive number and remain as it is. 4 become 4, 3 become 3. So if you change this, become like this, so 4 it become 2, 6 become 3. So it different then. But in this case, this is the line. ReLU in this case, you have like this, okay? So in this case, simply follow the thing. 4 here, then this 4 become 4. 3 here, it is 3. 4, 2, and negative 4. Negative 4 is here 1, 2, 3, 4. Negative 4 here, then it become 0. Okay, so that is the ReLU. Basically, ReLU removing the negative value. Set the purpose. Under one negative, how do we gonna change? I just put the value. I just do the ReLU and everything will be. So it is 0. This is the graph of ReLU. So it is a positive, don't remain positive. It is negative, so I put it 0 here. There's 0. So this is 11, so just remain the number 0, 11. Okay, 0, 11. And 0.33, 0.5. This is negative, so it is here become 0. This is 0.3. So that's ReLU. Basically, in this case, if you use ReLU, basically removing the negative value. Okay, finish. Pooling layer. Pooling reduce the dimensionality focus most important element. Okay, in this case, you got this is the output. The output here, this is the output. This is the output. Okay. So the output will go to pooling layer. And again, you got another filter. So this is the value. A filter 2 by 2. Two by 2. 2 row and 2 column, 2 by 2. And then in this case, 3. I take the maximum. So this is called maximum filter. Kita ada 2.0, 3. So when I move this filter here, take the maximum. So 3 is maximum. Put there 3. Okay. So move to the next one. Move to the next one. Okay. You cannot overlapping. It's just next to it. Okay. Move to the next one. Here. Take the maximum. 5 is the maximum of all. Put it 5. Then move a little bit here. Look at this. Take the maximum. 7. Put it 7 there. Okay. So this pooling layer, I use a maximum. You can say that in this filter, take the minimum. 1.5. You can put 1.5. It depends on what you're going to use. Move to the next one. Take the minimum. 0. So it becomes 0. Move next one. Take the minimum. 0 becomes 0. Okay, that's one thing. Or probably you can take the average. If you take the average on this one, take the average. 2 plus 3, 5. Plus 2, 7. 8.5 divided by 4. 2 point something. 2 point average. 2.3. And move next. Take the average. 0 plus 5, 5.5, 5.5 divided by 4, average 1 point something. And so on. So this is a pooling layer. You see now, you got how many? You reduce the size. So you got 1, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. When you do 2 by 2 filter, you reduce half, become 3 by 3. This is 6 column and 6 row. It become 3 row, 3 column and 3 row. Simply because you use 2 by 2. It reduce half of it. Okay, so it is called dimension reduction to reduce the size of the original or the input. So we reduce the dimension. So the complicated of the things we reduce into half. We don't deal with the whole big thing. We only deal half of it. Because people see that this number, this is the important one. This is the important one. This is the important features that we want to do. And the rest is not so important. So delete it. Throw it away. So I threw it away. So that's the purpose of pooling. Okay. All right. Now, okay, I think finish now, okay, with the convolutional neural network, okay? So now you understand that the convolutional basically, you got this convolution, ReLU, pooling. You can do another again, convolution, ReLU, pooling. You can do and so on until you stop. Convolutional, ReLU, pooling, then repeat again, convolutional, ReLU, pooling, then repeat again. At the end of the day, yeah, Hanisa, I just pause, yeah. No mind, I'll fill it later on. The missing part, I'm gonna put, okay? And okay, now this is what we learned from the previous one, previous work, okay? This is the previous work. So now you got this one. All right, and so this is what I draw. You can also draw like this, original one. Then use filter. I have 40 filter. It becomes 64 now. Now 64 I use pooling here. So here this is the original image. This is how you read it. This is the original image. Okay. When I use filter, say 5 by 5 filter, and ReLU, I use 40 filter. I got 64 by 64 now. Reduce a bit. So this is half. I think it is pooling. They reduce into half. So I got one convolutional, one convolutional, one convolutional. 1 to 8, 1 to 8. When I use pooling, it cut into half, 64. So here I got convolutional, ReLU, and pooling. It cut the original into 64, and I got use 40 filter. This is how you read it. Then you move around, you do another convolutional, ReLU, and pooling. In this case, 64 become reduced half. You know, pooling, it reduced 6 by 6 into 3 by 3. So it reduced the size of half of the original size. So in this case, it reduced half. So here you got convolutional, ReLU, and pooling. And here again, now here you use 80 filter. In this case, you use 300 filter with different value. So 32 is cut into half. So convolutional, ReLU, and pooling now become 16 by 16. Now, then I use another 800 filter. Now I use convolutional ReLU and pooling. The size is cut into half, 8 by 8 now. So now 8 by 8. So I'm going to stop here. I think that's enough. So these are basically the features, important features. Features learning, okay? So at the end of the day, these are very important features that I need to use on this image. So these features basically are the important features of the image. So this image basically, these are the important features. We are not taking pixel by pixel now. We are taking these features. Features mean kalau bank loan, the features is age, are you married, your income, how many car you have before the approved in loan, before the loan is approved. So in this case, images, the features is like this. What are inside there? Well, it is a number represent something. I don't know that, okay? All right? But something important of the series thing. Then this will be moving into being flattened now, okay? With 2 by 2, 2 by 2. So this basically 2 by 2. Two by this one basically you can see like this. Okay, so this is 2 by 2, another one, okay? 2 by 2. Okay.
Doctor, I have a question.
Yes.
How do we know that how many rounds of convolutional that we need to do to get the features that we wanted?
Oh, that's a good question. Basically, you have to done basically the real things you have to done with the experiment. You can do until here, stop, and skip to go to neural network, or you can until here you stop, then go to neural network, see what happened, and until you stop. But mostly people until 2 by 2, 4 by 4, 8 by 8 of the things. Okay, so okay, so it done. We don't know how. It depends on the context of problem statement, and then you have to try. If I just do one convolutional, is the output is okay? Is the prediction is okay? Accuracy is okay? If which is accuracy is already 80%, 90%, I think it's okay. Then when let's do two convolutional. Then the accuracy, all those things is still the same. So you better stop at the first or the second. The more smaller at the end, the more smaller, so neural network, the input becomes smaller. If you put this one, the input is bigger compared to this one.
Okay, so
Okay?
it's like trial and error.
Yes, try and error. But we, in case small, then it doesn't matter you stop where. If it is too big, we need to reduce until, because it consume processing, you know. If you got 1,000,000 images, for example, it's big. How many days you want to process? So it's gonna reduce a lot until it becomes smaller. So it depends on things. Depend on data size of data set, size of data sets, depends on accuracy. So trial and error. So 2 by 2 basically like this. You got 2 by 2. Now you just flatten it into one row and one. Okay, something like that. Okay. Then after that you just put into the neural network. So this is where classification. So this is become, what is this? If it is a car, then you can have here car, here is else, not car. Only two things. We only interest in car. Else means not car. Simply like that. Given a picture, then he said that it is a car. Given a picture, it is not a car, so it else. So what this fully connected layer, you got bias and weight. When its target value, when the loss is zero, mean it is they learn already. So when it loss becomes zero, the weight and bias and number of layer, number of node will be stored permanently because that's the important value. This is important, okay? The concept. Okay? So I repeat again. When you do on training, you have car and else, it gonna learn. When when loss is zero, it mean it learn. It has done a sufficient learn of say 1,000 images, and all now losses become zero. When loss is zero, the neural network is learn sufficient. When loss is zero, when you go propagation back and forward, at the end of the day, you got a final value of weight and bias. When loss is zero, the value of weight and bias of each node will be stored permanently to represent the characteristic of the learn. And the number of layer and nodes will be fixed now. You cannot change anymore. So when loss is zero, that means everything you specify here, the last number, that will be the value going to be stored permanently. Because this value bias and weight and number of layer and number of node, it's meant to be this experiment car. So you store it permanently. So you can bring this to anywhere because it already has a value, weight and bias and fixed already. You cannot change. If you change, then you need another experiment and then the learning will be different. Okay, got it? Alright, that's the purpose of training. When you do sufficient training, okay, loss is zero, then you're gonna stop permanently whatever the final value here. It represents the learning at the end of the day. Its weight and bias and number of layer. So you can use this for other purposes. You just change the value and you can use the same things. But it really depends on the problem statement if you want to. That means you transfer learning. You train this for a car and else, and you got fixed value and fixed bias and weight and layer and nodes. When you took this to other problem domain, it means transfer learning. And then you're gonna check. This learning here, you bring this to the other. Okay, to the other domain, EEG, for example. So you just use the existing one and use it there. So this is learning already. So when you use in somewhere else, it means the learning is be transferred to some other thing, some other domain. Okay, got it? That's mean transfer learning. It's just like you learn something, then when you something new, you try to adapt what you're learning before to adopt to this new what you see. That's transfer learning. You just learn from the experience, learn from the knowledge from other, apply to the other. That is transfer learning in this case. Okay, I think that's it because this is a lot basically. Okay, and we're gonna summary is basically this. Okay, You can do series of things, and convolutional has filter and pulling, cut into half. So this feature learning, at the end of the day, we're gonna use feature learning like a previous lecture. So I'm gonna stop here and gonna take 5 minutes break or 10 minutes. After that, answer and question anything. This one or the previous lecture. Uh, Anything you don't understand from the previous lecture or this one, please ask to me after the break. Okay? So after this, no more lecture like this. It's just questioning and answer. I'll be here. Just you can, since you're on in front of computer and we are in the class, you just go back and make revision for the test tonight. And if you have any question, just please ask me. Okay, we're gonna break for a while. Okay, we're gonna pause. Okay, and okay.